Hello friends, welcome to PSCAD tutorial. In this tutorial, we will learn how to build new component in PSCAD. So you know masking in MATLAB. Masking means putting a big complex system into a small box, so that the model looks simple. So this kind of things we will do in PSCAD by building new components. So for that, some complex modeling should be there. So I'm not giving much complex modeling. So I just introduce fixed capacitive compensation. Suppose first just mm, switch off the fault. So how to switch off? Just make it 20 as the runtime is. Our runtime is 5 seconds. So 20 seconds will not appear in fault will not appear in 5 seconds. So at first go to here. Uh, our XL positive sequence inductive reactance is 0.327 and our line length is 60 plus 40 means 100. So 100 into 0.327. Okay, so our line impedance line reactance is 32.7 ohm. So if we want capacitive compensation, say about 30% of the total reactance, so this will multiplied with point 3 means 9.81, right? And 9.81 is in ohm, right? So what will be the value of C? We know that XC equals to 1 by omega C, right? And omega equals to nothing but 2i into pi into f. So equals to 2i into uh, pi into f means 50. So 2 into pi into 50. So 314.16. So equals to 314.16. Okay, this is our omega, and xc is 9.81, which is equals to 1 by in bracket 314.16 into c, right? So our c will be equals to 1 divided by 9.81 into 314.16. So this will be equals to 9.81 into 314.16 equals to 1 by this. This will come 3.24 3.244 means 3.244 into 10 to the power minus 4, which will be equals to 324.4 into 10 to the power minus 6, right? This is micro, this is in, so 324.4 will be in micro, right? So let's check out the power flow in the transmission line first. So just see the active power flow is 769.7. So we want to introduce a series compensation of 30%. So just make it here. So this is our splitter. Okay, single phase to three phase splitter. So this is our capacitor, and capacitor value is 324.4 microfarad. 324.4. Okay, okay, just copy it. Okay, now connect it. Okay, now just copy these things. Okay, just select this and just mirror this by pressing M. So now connect this with it, and line will be connected by there. So this is our 30% series compensation. We can write in sticky note also 30% capacitive compensation. Okay, so this is our 30% capacitive compensation. So if we run this, the power flow will be more. So you can see that the power flow is increased, right? At first, without series compensation, the power was some 700 and something. Now 1157. So power flow is more. So this is our series compensation, right? So fixed series compensation is done. Now how to create a new system? Okay, how to create a new block for this series compensation? New component block. So just right click on the model window and create new component. Say this, name the component as, say, capacitive compensation. So right here, this will be your display name of the display. Okay, uh, so this will be capacitive compensation. Now connection will be two, here one input and one output, right? So left one, right one. You have to check the page module. Okay. So this should not be spaced. Underscore giving underscore. So first connection name, say name it as in. Okay, and this is say A, display level, and this is electrical connection, and dimension is 3 for 3-phase line, right? And then next, this is out, and this is B. This is also electrical and dimension of 3, right? Go to next. Okay, finish. So this is our capacitive compensator. Compensation. Okay. So you can see that the name is not coming properly. So just right click on it and go to edit definition. Just copy the connection name and increase the increase the increase the length of the box, right? And place it here. Now just cross it and go to power system again. So this is looking good. Now just copy this thing. Okay, and just cut this thing by Control X and paste it here. This may be our big system. For example, I am taking a simple system, but this may be very big system to look good, uh, to look the this window good, not so much complex. Just connect it here by connection of this. So in this is our system. So just run it and check it is working properly or not. So this is as it is. So building of new components work is complete. Now take the fixed capacitor and fixed capacitor and change the capacitor to fixed value to variable value. Okay. For this, go to master library and this is our variable capacitor, right? Just copy it by Control C and go to here and paste it and just give the capacitance as C. Okay, and this is okay. Just delete this. Okay, just copy this and paste here. Okay, now the fourth point is control from outside. So control from outside. So here the transmitter and receiver will act. Uh, from outside we transmit the value of the C and here we will receive. So this is received already and signal name is say C and dimension is 1 for single phase operate. This is individual phase, so dimension is 1. Source module, what is cap? Okay, and just connect a wire and give a signal name C. Okay, and just copy these things. Okay, let's go to back and make it transmit. So this is our transmit, right? And just connect a wire and signal is C. right? Now, what will be the value of C? How we can change? How we can change? We can change from maximum value say 500 microfarad and minimum value is say 200 microfarad. Initially is 100 to 50 microfarad, right? And this is our C. This is a slider. Just display this title of this icon is a yes, and this is to be transmitted, right? So just add a control here. Just right click on it, go to graph meter and control, add to meter, and right click on it and paste it here. Oh, this is not meter. This is not. Just right click, go to graph meter and add as control, and right click on it and paste it here. So say two near about 250, and just run it. Oh, some error is coming. To check out the error, just what is the problem? Does not transmit. Mm, Sorry for the interruption. I have no clue why transmitter and receiver is not running. But there is another way to control the variable capacitor from outside. Um, just I connect a connection called C. Just go to edit definition, and this is our C. This is our C, and the properties of this is symbolized as CAP, and this is a single dimension, and this is input data. Okay, so and this is a rotary switch where three dial positions are there. First dial positions implies 200 microfarad, 300 microfarad, and 400 microfarad for position 1, 2, and 3. Okay, and just right click on it, go to graph parameters, add to control, and uh, take a control panel from here and paste it, and it coming like that. Okay, so position 2 is 300 microfarad, position 4 is 400 microfarad, position 1 is 200 microfarad. Okay, so in here the same name of the capacitor, this is cap, is this is a single signal name, and just go back to this and go to edit definition, and this is the name CAP is in small also. So you have to just import the signal from import. You can have the import from here. So you have to change the name as cap like this, and just run it. Now 200 microfarad, so power will be less. This is the power for 300 microfarad. So oh, no, actually less capacitance means more capacitive reactance. More capacitive reactance means capacitive compensation will be more, so power flow will be more. And if we go use 400 microfarad, so capacity compensation will be less, and our power flow will be less. Yes. Okay. So fourth point is complete. And edit definition, I have already done it, but once again I am going to just edit definition. You can uh, just you can draw various things. You can and make it as circle. Just delete it, delete it, and make it as circle. You can do anything else. This is like circle. Okay, then uh, go again, and you can just you can make dotted lines here also. Dotted. You can change the color as well. Okay, this is transparent, and so you can change the color. Okay, just right click on it, send to back. So the name will come like this. So you can change the color, and you can. This is solid fill. You can change like this also, like this also. So this is the way to change the appearance of the block by going to edit definition. So I guess all the points is covered. So this is end of this tutorial. Thank you.